Today we're going to take a look at verifying a trig identity. Remember, an identity is really just an equation. It's also always true. So we're not going to plug in angles. We're just going to try to work one side to get it to be the other. So this is exactly what we were doing. We just now have the answer. So they tell us where to stop, right? So they tell us, hey, when you get to cosine squared, stop. Some strategies on this: pick the side that's more complicated. For example, addition is more complicated than multiplication. And in this particular problem, this first problem, you can see obviously that this side has an awful lot going on, whereas the other side just says cosine squared. So there's not a lot to go from when you're just going to start with cosine squared. So I would pick the more complicated side. Another rule: you're not allowed to go side to side. Like, for example, we could not add sine squared to both sides. All right? Even though there's an equal sign there and it looks like an equation, they're telling you it's an identity, which means work one side until you can get it to be simplified to be the other side. Again, the hardest part about this is to knowing where to start. So get those trig identity paper, get that little half sheet ready, because we're going to look at that an awful lot. Now, this is not a proof, so you don't have to state what you're doing. If you do this topic in ALEKS, they do require that you state what you're doing. So I'm going to just factor out sine squared. If you do this topic in ALEKS, this would just be considered algebra. So they don't really differentiate between factoring, combining like terms, FOIL, any of that stuff. They just call it algebra. So the reasons are pretty generic. But we're not going to do that. We're just going to do the problem rather than explain what we're doing. So if you take out a sine squared, if we take this out, basically we're dividing without dividing, right? That's what factoring is. We're dividing it and we keep what we divided by. So when we do this, sine squared divided by sine squared is a -1. Now remember, anything that you have that has a term squared is probably a Pythagorean identity. And so if you look at the Pythagorean identities, I'm going to put this over here to tell you what I'm looking at. We have 1 plus cotangent squared equals cosecant squared. So if we were to subtract 1, then we would know that cotangent squared equals cosecant squared minus 1. So we're going to take out the cosecant squared, and in its spot, we're going to put cotangent squared. Now, you don't need to write this. I just wrote it on here to show you what I was using. So this is coming out, and we're going to just use some substitution, and we're going to put cotangent squared in there. Sine squared is still on the outside. Now we really don't know what to do, so we're going to switch everything to sine and cosine. Sine squared stays itself, and cotangent squared is cosine squared over sine squared. Since we're multiplying, we can reduce it on the diagonal, and you can see we have cosine squared left. So when you're done, please write the answer. I know we can see the answer. It's not a mystery. We know what the answer is. It's just the other side. But please write it down so that I know that you're finished. Generally, when we see parentheses, you're probably going to multiply or use FOIL. So this is just going to be distributive property. I am going to work the left side on this one because, again, there's more going on. So this is tangent squared x. And then tangent times cotangent. I'm going to write this out. Tangent x, cotangent x. It's really a 1. But if you don't know that, that's no problem. Because if you switch everything to sine and cosine, you'll see that it cancels. So tangent is sine over cosine, and cotangent is cosine over sine. And now everything is gone. Now you could skip that step and go right to tangent squared plus 1 if you'd like, because these are reciprocals, so they do multiply to give you 1. And then if we look at the trig identities, tangent squared plus 1 is secant squared. And that's what the goal is, so we're finished. Now in this next problem, I can see we have cosine squared, but we've got a lot of words. There's a lot of different words on this one. So I'm going to do the left-hand side. All right, so I'm going to definitely work this side. So my goal is to get it to say cosecant. If you don't like theta, you can use x. I don't really know what to do with this, so I'm just going to switch everything to sine and cosine and see if something can cancel. Whoa. It's extreme. So we're going to switch cosecant to 1 over sine times cosine squared. Well, we can't do much with that, so we'll leave it cosine squared. Plus sine is obviously sine over 1. Order of operations. Don't forget, multiply, my dear Aunt Sally, so multiply comes first. So this is actually cosine squared over sine, if we turn that into one fraction, plus sine over 1. We are officially going to add fractions. We have only one denominator, so our common denominator is going to be that, which means this one needs to be multiplied. We already did the bottom. Whatever you multiply the bottom by, you multiply the top by. And so now on the top, we have cosine squared plus sine times sine, which is sine squared. And we know that cosine squared plus sine squared is 1 from the Pythagorean identities. So that's 1 over sine. Keep one eye on this answer so you know where to stop. 1 over sine is cosecant, and we definitely made that look like cosecant. Let's see, number 4. I'm going to work this side, this right-hand side. Looks like problem number 1, really, where we're going to factor, because they both have a cosecant squared. So we're left with 1 minus sine squared. Your Pythagorean identities, 1 minus sine squared is cosine squared, and this is obviously cosecant squared. Switching everything to sine and cosine, 1 over sine squared times cosine squared over 1. Straight across the top, straight across the bottom. Now keep in mind, this is where we're going. We're trying to get cotangent squared. So now we have cosine, oops, I'm not sure what that is. Cosine squared over sine squared. I don't know what I'm doing here. And now that's not going to erase. Okay, cool. So now we have cosine squared over sine squared. And cosine over sine is cotangent. If they're both squared, then the cotangent is also squared. Last one. 1 plus cosecant squared. That's not a thing, unfortunately. So we're not going to be able to use a trig identity there because it's cosecant squared minus 1, if you remember from up here. So it's cosecant squared minus 1, and that's not what we have. So similar, but it's not exactly the same, so it's not usable. So I'm going to work the right-hand side, and I'm just going to leave this 1 plus cosecant squared. I don't really know what to do with that yet. But 1 plus cotangent squared, that is something. That is cosecant squared. You cannot cross off those cosecant squares because the top part is adding and the bottom part is multiplying. Those don't undo each other. So don't just go, oh, look, they match and cross them off. That's not how this works. That's not algebraically sound. So on the top, this is obviously a 1, and cosecant squared is 1 over sine squared. So I'm going to add these two fractions together. So I'm going to need to make this, you can turn 1 into anything, so I'm going to turn my 1 into sine squared over sine squared. All right, I could turn 1 into 5 over 5, I could turn 1 into radical 2 over radical 2. So I'm going to just make it sine squared over sine squared. I just wrote right on top of it so I don't have to rewrite it. So now on this top I have sine squared plus 1 over plain old sine squared. And now this is being divided by cosecant squared. So just to rewrite this, I'm just going to come up here. If you don't like the complex fraction, then don't write it like a complex fraction. This is divided by 1 over sine squared, right? Because that's what cosecant squared is. I just took this and made it 1 over sine squared because that's the same. So when you divide fractions, you take the second one and you flip it over and then you multiply. All right, so the second fraction is going to have the reciprocal, so sine squared's on top. Now you can see these cross off. Remember, look at the goal. Don't forget to keep looking at the answer. It's right there to kind of help you figure out if you're getting close, to figure out if you're finished. And so that's exactly what the goal was. It doesn't matter. 1 plus sine squared and sine squared plus 1 are the same thing because you're adding, so the order doesn't matter. So that's how that one is going to work. So again, when you're doing the assignment, just try it. If as far as you can get is the first step and you don't know what to do, stop. If you can't get past you can't even do the first step, move on to the next one.